A particle is projected horizontally with speed 15 meters per second from a point 30 meters above a horizontal surface. And we want to calculate some things. We'll come back to those. Let's just draw the situation. So this is 30 meters and horizontal projection 15 meters per second, and it's going to do a path like this, and after 2 seconds it's going to be at some position just here. All these questions are about 2 seconds. So we know that acceleration due to gravity acts vertically downwards, and let's take downwards as positive. So what we want is the distance covered here. So that's what we want. We know that this is 0 because we're considering the vertical motion. We don't need to know this at the moment, but we will need it for part B. So we'll come back to that. A is 9.8 and T is 2. So for this part of the question, we're going to use S is ut plus a half at squared. So this part's going to be 0 because of the u being 0. Half of 9.8 is 4.9 times 2 squared. And so 4.9 times 4 is 19.6 meters. So if it's travelled downwards 19.6, 30 take away 19.6 is 10.4. So the height is going to be 10.4 meters. Now in part B, we want horizontal and vertical components of the velocity. Well, the horizontal we know is not going to change. So that's still going to be 15. And the vertical, that's what I said we needed here. So if we use that, we can use V equals U plus AT. So U was 0, so it's going to be 9.8 times 2. So V is going to be 19.6 meters per second. So this is 19.6 meters per second. And so for C, we want the speed of the particle. So what we've got is 15 this way, 19.6, well actually that's downwards, isn't it? So let's just draw it. That's 15 that way and 19.6 that way. And then we'll use Pythagoras' theorem. So the speed is going to be the square root of 15 squared, add 19.6 squared, and that gives me 24.7 meters per second, and that's to 3 significant figures.